Hello and happy Tuesday. My name is John Kowalski. I'm part of the marketing team here at BIC Instruments and I'd like to welcome you to our latest webinar on dispersing and milling for energy storage. Definitely an exciting topic these days. So today's presenter is Mr. Andy Stummer. He is our business line manager for dispersion and milling. He'll be presenting today. Also, if you have any questions, please log them in the chat located in the bottom right-hand corner of your screen. I don't expect we'll have time to get to them. This is a pretty in-depth presentation, but log them in and we'll make sure Andy or someone on the team follows up with you directly. Also, take note, we are recording this, and immediately following, you'll receive a marketing automated email with the link. So feel free to watch again and share it with colleagues, whatever you like. So with that, let me turn things over to our speaker, Mr. Andy Stummer. Andy, it's all yours, sir.
Thank you, John. Thanks, everybody, for joining us today. We're supposed to have this meeting a week ago. Unfortunately, I fell ill with the virus and couldn't really talk. So today my voice is much better, and hopefully we get through this without any issues. So just a quick introduction about modern energy storage, then we go right into the dispersing and milling process overview. We have also some exciting news and new development for that particular market. And then we cover lab and production equipment, different models we offer for different energy storage capabilities, applications, and then we talk about lab capabilities at the end, what we have in Germany and in Wallingford, Connecticut at our sister company, BIC USA. As you can already see on this slide, we cover everything, what we offer models from small laboratory applications all the way up pilot and then manufacturing. We even have larger models than what you can see on this picture right here for very large volume applications. We're going to cover that as well. So basically, most of you are familiar with lithium-ion energy storage solutions. So not a lot of news there, but the technology is really improving a lot, especially the last few years. We have seen really quite a good increase in performance, better range, power, and also with new developments, shorter charging times. So it's really important to select the right equipment, right dissolvers, as well as milling technology, and as well as additives that go into these slurries to give you really the best performance and development on also manufacturing capabilities. So solid state is kind of the next step up in the development process. So we have some good results there with our milling technology, especially those separators. And then obviously Big Gardner and VMA, we offer really some good solutions for the traditional lithium-ion battery development process, as well as the new type of solid state batteries. And we have that new Dispermat design that we'll talk about shortly to really give you optimum performance in the lab space, pilot, as well as manufacturing. So just a quick overview. So here is the demand for lithium-ion batteries. That slide was shared to me, given to me by our sister company, BIC Additives. They supply some of the raw materials that go into these batteries, and you can see it's really exponentially how we are growing in that industry. So a lot of good news stories there. And so our type of equipment, the dissolvers, as well as the different types of media mills, including horizontal mills or the basket mill designs, are really used to process different components that go into our slurries. You can see a list right here: silicones, different electrodes, silicon oxides, lithium, also these separators made of ceramic components, and carbon graphite grinding as well as dispersing carbon blacks go into these slurries. All of that, those additives or components basically work really well with our different types of dissolvers. So the battery development, so we have these electrolytes that are inside of our battery that allows basically the ions to flow in between the anode and the cathode. They can either be fluids or solids. And then basically these different acid salts generally act as these electrolytes in these slurries. And we need to really have very good dispersing and milling equipment to develop these electrolytes by basically reducing our particle size, have very good homogeneous slurries that will then improve our transfer efficiency of ion particles moving from the anode to the cathode. So we have some of the different types of mixing equipments and dispersing equipment we'll be covering that will help us to get better performance of our batteries. Okay. So here is the new Dispermat line for the renewable energy market. It's called the Dispermat AE-RE for renewable energy, and VL-RE, which is a vacuum dissolver. They all come now with a new torque measurement system that is integrated. So we no longer measure all the values like power, speed, torque value through the frequency inverter. It's actually measured directly with its own sensor mechanism. You can see that right here on that picture that's attached to the shaft. And we are literally measuring very accurately the exact speed of the shaft as well as the power and the torque value. All that data is transferred over to our control panel, and we can visually see the exact precise values of these measurements, much more precise than we would be getting with the standard frequency inverter readout. So this is a whole new development, and there is also different sensors depending on the amount of torque the machine needs to put in to process the different volumes of slurries. So we have extremely good repeatability and reproducibility with this system. And obviously we no longer need the data from the frequency inverter. Everything is measured directly on the shaft with that new sensor. So it's a really good, reliable development tool, as well as then obviously you can integrate the same system into a pilot or manufacturing unit. So here's an example of new Dispermat AE renewable energy with the torque measurement system, how we mill or homogenize carbon black. And so here the different ingredients that go in, PVDF binders, different additives, our active materials, and obviously idea is to develop a really good cathode slurry with the carbon black. So here's an example of a system where we actually pre-dispersed with the CN20, which is one of the dispersers. This was before that new development, but it's based on the same platform. Also using a basket mill. So we started out at about 100 microns of particle size. We pre-dispersed the slurry with the Caluclation blade for about 1 hour. And then we milled with the basket mill TML1. We'll talk a little bit more in detail about this technology for about 3 hours. And then we were able to reduce our particle size to 2 microns on average, which is really good. Very quick milling time, very scalable. This was done in the lab space. We then later on did larger volumes in our pilot scale facility, and we were able to get exactly the same results with our basket mill for that cathode slurry. So what happens right there is obviously in the dispersion process, we're trying to wet our solid particles, a mechanical breakdown of our larger agglomerates, and then basically turn them into aggregates, which then in return, if we actually would do the real milling, would turn them into primary particle size, which becomes really important when we are dealing with our separators where we need extremely small particle size, somewhat in the lower nano range. And then at the end, we want to use the right additive package to really stabilize our particles when they are in a suspended state. So here is actually the entire process. So we're wetting first, we are pre-dispersing with the Kaul's blade, and then when we reach the desired particle size of our aggregates and we want to go smaller, that's when we need to do actually the media milling, and then finally we want to stabilize our slurry with the right additives. So here is an example. I will play this video here. So actually, John, since you are hosting this slide, maybe you can play the video.
Well, it's in the system. Videos are always an issue. Let me see if I can pull that up here another way and share my screen if that would work. Let's do this.
Okay, so if we're not able to basically on this video, we would be showing you how to mill carbon black with the basket mill TML1, what we talked about before, where we were able to reduce the particle size down to 2 microns in 3 hours of milling time. So a big additive was basically supplying us with the dispersing and wetting agent as well as a defoamer called Liponite RD. We can also put you in touch with our colleagues on the additive side that can talk to a little bit more about the specifics of these different additive packages. So here is an important slide. So we always want to start out with the dissolver, which is using the Kaul's blade to basically mix and homogenize, pre-disperse our slurry. And then when we reach about 30 microns of particle size, this is kind of the threshold, down to about 10 microns, which is kind of the lower limit, what we can achieve with just the Kaul's blade. That's when we're going to start media milling. So we can either use a basket mill or a horizontal bead mill or vertical bead mill to accomplish that, and then allows us to go down to really low nano range for very small particle size requirements. So we have 2 different steps. So we got the pre-dispersion step, we got different types of dispermats, dissolvers. Very important, 18 to 25 meters per second is our tip speed. That's what we're looking for. And then when we are grinding or milling, we're looking for about 10 to 16 meters per second of our tip speed of our milling disc or our rotor. So we have vertical bead mills, basket mills, our tourist mill TML, which you saw previously. And then we also have the Dispermat SC with quick change system, which allows you to very quickly transition between a disperser as well as a basket mill, go back and forth, so you don't have to buy 2 pieces of equipment. Your entire development process can all be done on 1 piece of equipment, which is really nice. Don't need as much lab space or manufacturing space. Everything can be really done on 1 machine. Or we have also the horizontal bead mills, which allow you to go down to super small particle size, smaller than 50 nanometers. We have our RS series for manufacturing, as well as the SL for the lab space. And we'll talk a little bit more in detail later on in the presentation. So to start out with, we always want to make sure when we pre-disperse or we mix, we want to always use the right dissolver disc to container ratio. We recommend about 1/3 diameter of our blade to container. And then basically on the right side here, there is a slide that will show you the sweet spot for each container, volume, and the blade diameter that you should be using to properly pre-disperse your slurry. Obviously, you have some ranges depending on the viscosity. So not one blade fits every container. So you can really see, for example, if I'm in the laboratory space, I have a 1 liter vessel. I can go anywhere from a 70 millimeter blade down to a 30. As long as I'm hitting my tip speed of 18 to 25 meters per second, I'm good. I can use any blade in that range to make sure I produce a very good quality slurry. So the other important part is what we already talked about is the tip speed calculation. So we have tip speed calculated is the RPMs multiplied by 3.14, and then also multiply that with the diameter of our dispersing blade. If we want meters per second, we want to use that in metric. So if I have a 50 milli blade, would be, for example, 0.05, and then divide everything by 60. And that number should be anywhere between 18 to 25 meters per second. If I'm using a dissolver disc, if I'm milling, that should be anywhere between 10 to 16 meters per second. But the same formula applies to pre-dispersing as well as milling. That's a really important formula. You want to write that down. It's not only about the RPMs, it's really about the actual tip speed. This is also why you will see smaller lab units have much higher RPMs. We can go up to 20,000, and very large production machines have much lower RPMs because of the diameter of the blade is much larger in a manufacturing environment than what you would see in a laboratory space. So it's really all about the tip speed, what we need to watch out for. Then we have, it's really called the donut effect, is a very important visual cue that we actually see when we look inside of our container when we are pre-dispersing. So when we optimize our dispersion parameters, optimize the tip speed, you should, and also the mill base, about 50% of the 50 to 70% fill rate of our container. We don't want to go higher, otherwise we are spilling. And we optimize the parameters. We should really visually see the formation of a donut. You can see that really well right here. You want to see that the blade is somewhat exposed and that you can actually see the center part really well. That means we are probably optimizing, or most likely optimizing, our dispersion process. Also, if our viscosity is in a good range, and I'll explain that in the next few slides. If the viscosity is too low, we may still be pre-dispersing, but we won't see a donut because the donut would automatically collapse once it's being formed. So here is a good slide showing you where actually the breakup of these larger particles takes place. It's actually at the lip of our blade. Also, you would have the same effect on the bottom. It's not on this picture here, but you would see both on the top as well as on the bottom where this deagglomeration action actually takes place. Here's an example of a slurry. Same effect applies to a battery slurry. This picture was taken with the coating, but you see an optimum dissolver prep right here. We're putting in 21 meters per second, 850 watts of energy. So you can see the donut. Over here on the next one, we're putting in 320 watts of energy at the same tip speed, which means that the viscosity of our slurry is very low. Doesn't mean we are not dispersing, but just means the viscosity is so slow, no donut can be formed. So it'd probably be better to modify it so you can increase the viscosity somewhat to get the donut and also to be able to put in more energy into the slurry, which is important in our deagglomeration process. And here is an example of where we're putting in 900 watts of energy. We're not seeing a donut. This means that the viscosity is really high, and we are probably not able to ever see a donut. Doesn't mean we are not dispersing. It just means that the viscosity is just so high that we don't really get the donut formed. Okay, so for the pre-dispersion process, which is that first step, really important, duration of our dispersion process, depending on our formulation, can be anywhere, up to like 1 hour. What we have seen, certain applications, usually about 15 to 20 minutes, but up to an hour. And then we want to be able to see the donut effect. Ideally, always try to stay within 18 to 25 meters per second of tip speed. Again, we want to be about 1/3 diameter ratio our impeller or dispersion blade to our container. Also want to choose the right type of impeller. There's many different ones on the market, light duty, heavy duty, depending on the viscosity. We want to stick with about 50 to 70% fill ratio, not more. Otherwise, we are spilling. And if we have less than that, then we're not able to properly oscillate up and down. So that could be an issue as well. And if we are basket milling, if we have less than 50%, the mill will actually touch the bottom of our container, and that could also affect the milling performance. Carbon black, zirconium, and filler concentration play a role. Low temperature is important. We will try to be as cool as possible. So we have also double wall containers that will help with temperature regulation. And then again, the right additive package is important for better wetting, dispersing, no flocculation, and also to keep the foam in check. And then once we achieve a good pre-dispersion result, we can then move over to a bead mill to get smaller particle size if we need to. So the difference here really is obviously with a dissolver or a disperser, we only have a Cowles blade. Because we only use a Cowles blade, the energy input is somewhat limited, means also limited amount of shear force. It's really only for the first step to de-agglomerate and get us down to the aggregate level, not to the primary particle level. But it is a really critical step in any type of dispersion process that we first use a dissolver before we do any type of milling. The reason is in mills we have dynamic gaps, so we have screens, and if our particles are too large, the screens could get clogged, or our dynamic gap would be clogged. Also, our beads may not have the right kinetic energy to really break up these binding forces of these larger particles. So we want to pre-disperse down to 30 microns, between 10 to 30 microns, and then we want to start the milling process, where we're able then to put in a lot more energy, really break down to primary particle size. Again, with the basket mills, we're able to go down to about 500 nanometers. And for really small particle requirements, like your separators, where we need sometimes smaller than 100 nanometers, we really need to use a horizontal bead mill. That will obviously give us improved characteristics, better particle size, transparency, color strength, or particle size distribution, or some of the effects that you would see if you're properly milling your slurries. So what actually happens inside of a bead mill? Obviously, we're inside of a chamber, and the milling disc or the rotor will basically rotate at a high rate of speed and then throw around these beads or the media that we have in the chambers. And then basically, as these beads are drifting towards each other, that pushing action, that the fluid dynamics will actually cause the shear force to break up these binding forces. So that means that the larger particle gets pushed away with a really high velocity and then basically gets reduced to smaller particle size. It's definitely some crushing action there as well, but the probability of particle getting pushed between two beads is relatively small. So most of your particle size reduction will actually be caused by the shearing motion of the beads drifting towards each other at high velocities. So at that point, we're able to reduce the particle sizes below 10 microns. And we're also wetting. We need to stabilize with the right additives. And really, this is the real breakdown to the primary particle size inside of a bead mill. Very important, the kinetic energy of our beads during the milling process. So you might want to write down that formula. And weight of beads and peripheral speed of our rotor is our tip speed. That will give us the kinetic energy of our beads during the milling process. So very important when we are milling, we want to use high quality zirconium oxide beads. They're much heavier, much harder than, for example, glass. You can see right here, specific weight is 6.1 versus 2.5. So kinetic energy is much higher. Also, the Wicca hardness is much higher on a zirconium oxide bead versus on a glass bead. So always go with higher quality beads. You will have much better results. Also, glass tends to break up during the milling process. You end up with shards in your slurry, which would not happen with the zirconium oxide. For example, these are serum stabilized. We also have yttrium stabilized beads as well. So, but stay away from glass. They are no good. Here is a good slide. You can see the larger particles and then the beads colliding towards each other, drifting towards each other, causing a lot of pushing movement of the beads inside of the slur, of the particles inside of the slur, which actually breaks up these binding forces. And it's happening in these corners right here where that action actually takes place. So here are some critical parameters we have to watch out for. Again, particle size after pre-dispersing, 10 to 30 microns. Then we're going to move over to milling. Bead size, very important. We don't want to use super small beads if our particles are still 10 to 30 microns. We want to use 1 to 1.2 millimeter beads is kind of the sweet spot. The standard screen size we have in our basket mills is 0.5. So if you want to go with something smaller, you really should mill the slurry down with larger beads before you move to smaller bead sizes. We can go down all the way to 0.1 millimeter bead size, depending on the final desired particle size. Again, specific weight of the beads, try to stay with ceramic. They are much heavier than glass. Amount of beads plays a role. So they all have different requirements, whether you use horizontal basket mill or vertical bead mill. Shape of the beads, really important after milling. So many cycles. You should ideally always screen the beads, get rid of the fines. And also, you know, when you're using, or you shouldn't be using glass, that's when you see that there are shards inside of your slurry. You don't want to deal with that. So basically always try to stick with ceramic. And then again, tip speed, when we are milling, 10 to 16 meters per second, a little bit slower than when we pre-disperse, but that's the recommended range. Product temperature, we're going to put in a lot of energy during the milling process. So product temperature is going to go up very rapidly. So we definitely want to be able to cool not only our milling systems, but also the supply vessels or containers that we are milling in. So they need to be double walled. That's really, really important. Then obviously the number of passes, either through my milling chamber or my basket mill, will influence the speed of my milling as well as the final particle size, milling time, the residence time of my product inside of a milling chamber. If I pump it through really fast, okay, it's not going to be in contact with the beads for so long. So basically, the longer it stays in the milling chamber, the more milling action I get, and the smaller my particles will become eventually. Viscosity of the mill base, very important. If I have very thick slurry, very thick zootropic, I can't really use a basket mill. So the sweet spot there is about 3 to 5,000 centipoise. However, we can mill much larger, but it will viscosity, but it will take longer for the product to cycle through the mills. And then obviously, if our viscosity is too low, we can still mill, but it will also take longer because we're not able to put in as much energy due to our low viscosity. So that will then increase our milling time. And then again, the different types of bead mills, horizontal basket mill or vertical bead mill, will definitely influence our final milling result, particle size, as well as milling time. So our dispersers with Dispermats, they're well known in the industry. They have one key advantage, is that they're all modular. So you can see our clamping device on top, the clamping ring. You remove it, you turn that assembly 180 degrees, and you can basically pull out the shaft and then replace it either with the rotor stator, with the vacuum system, basket mill on the bottom right. We have a wall scraping system or vertical bead mill. Excellent solutions for lab space, and means you only need one piece of equipment for many different types of milling or dispersing formulations and requirements. So here is the RE model, basically with the torque measurement sensor. You can see the really nice C-control display that'll give you all the data on the screen, your speed, the amount of energy you're putting in, the torque value, which is an indirect measurement of your viscosity or change in viscosity. We also have the tip speed on the top right. We have a timer function, and as well as a temperature readout on display. All the data can be stored either on the actual control panel or sent over to a computer, where you then can review or view the dispersion process or milling process in real time, store the data. Actually, this particular C technology also allows you to create recipes for different formulations. And the next time when you're running it, it'll be able to recall everything that you're putting in, all the presets, energy input, speed, as well as cutoff values. If you have a certain threshold that you can exceed, for example, with your temperature, then you can put in a warning level. Let's say 50 C is the maximum. I can have a warning at 40 C, at 45 C, a second warning. And at 50 C, the machine will either shut off or run at a different speed. So you can then attach all these presets to a recipe, and they can all be stored on board or on a computer for use at a later time, or when you want to replicate the exact same trial or process. We also have explosion-proof models available. In some instances, customers require those. Same systems available for lab pilot as well as plant level. We use only direct drive brushless motors. If you have worked on a Dispermat, ultra quiet, you can hardly hear them when they're running, hardly any vibration of the motor. There is no belts or anything. The shaft goes right into the motor, and it's direct drive. So really, really well-designed motor and Dispermat system. So this here is the new VL renewable energy system. We have that model with the torque measurement sensor integrated. This machine allows you to basically disperse under vacuum. You can turn on the vacuum where you don't have to. It has basically a closed system with a viewing glass on top that allows you to also open that viewing glass to add more product, more powder or liquid additive. And then basically, depending on the viscosity, you can either engage or disengage a sweeper blade to ensure that all the slurry gets properly dispersed and the container walls are scraped free. You can then turn on the vacuum. Either during the dispersing process, it runs the entire time, or you just run it once, then close the valve, and then basically maintain a certain vacuum pressure inside of your vessel. Some customers also want to do dry dispersing. We can add a nitrogen purging valve, an inert gas. That's also an option that we can add on to the same system. And again, the torque measurement system gives you real-time, 100% accurate values of torque, speed, and also energy input. Then we have lower cost models. This is a model for the entry level, low cost, small benchtop applications. Just really a standard dissolver, also fully modular. You can add different milling accessories. It gives you a timer function as well as your speed dial. And then the disadvantage I want to point out on this particular model, this is my opinion, is that you have to manually raise or lower the shaft. You can see on the left, right side, that lever. You loosen that, and that allows you then to move the motor head with the shaft up and down along the stand. Personally, I don't like it that much because it's difficult to oscillate or find the sweet spot of the blade inside of the container. I much rather prefer the CV line, which actually very similar, except here you have the ability to raise and lower your shaft electronically. Also, the CV gives you a temperature readout, which is really important, especially when we are milling. It also gives you a torque value. Again, the torque value displayed here is calculated by the frequency inverter and is not perfectly accurate like what you would get with the new renewable energy systems that integrate that torque measurement sensor. And that can only be integrated on our higher end models that I showed you earlier. But with the CV, we can make up to 7 liters of slurry. Again, fully expandable. You can turn this into a basket mill or vertical bead mill with an APS system. I'll show you in a few minutes. Rotor, stator, or a vacuum system. Then we have the CN, which is a little larger system that also allows you to go up to pilot range within the same model family, same motor design, brushless step motor, ultra quiet, gives you, again, speed, percentage of torque, temperature, and timer. No torque measurement sensor like we have on the higher end model, but still gives you good data. And again, scalable within the model range. Ideally, if you want to have the same system for lab as well as pilot and small scale manufacturing, you can stay within the same product family. Here is the same model for larger volumes, but it gives you the same control capability. It's called the CN line. And then we have our flagship line, which is the AE, now with the renewable energy layout. And that basically comes with that C technology package. Here you can see a double wall container with the jackets. And then again, fully expandable to different milling systems, vacuum systems. Also within the same product family, we can go all the way up to pilot and small scale manufacturing. Again, the C technology allows you to store the data, send it over to a computer. We have a software called WinDisp, And then explosion-proof models are available as well within the AE range, which is really nice. They also come with what is called a net power calibration, which basically allows you to reset the machine to all the values to a complete 0 point, like the energy. So when you turn it on, you run that net power calibration feature. It will run without any product for 30 seconds and then reset all its values to a 0 point, so that when you're actually running product, there is no contamination of the values from the actual machine input itself. So all the values will be related directly to your slurry and not the machine input. And here again, AE for large scale, upscale to production. This is a small scale production. I'll show you the large scale production in a minute here. Again, same C technology package, what we already covered, giving you good upscale capability from lab pilot to manufacturing. Then we have horizontal bead mills in our portfolio. So we have the SL for the lab space, and then for manufacturing, the RS systems. These units are awesome, especially if you really want to go very, very small particle size. We offer full zirconium-lined milling chambers, zirconium rotors, really important for battery development. We can't have any metal contamination in our slurry. So we have those capabilities in our small laboratory scale models as well as our large manufacturing models. You can run them either in circulation mode or pass-through mode. The smaller units you can see have the supply vessel attached to the actual milling chamber. Above that is a small motor with a shaft and a pumping system that will actually force our slurry inside of the milling chamber, and then it gets recirculated back into our supply vessel. We have the ability to cool not only the supply vessel, but also the actual milling chamber as well, where you have cooling jackets for ultimate temperature control. Also, the same temperature control capability exists also for our manufacturing scale RS systems. Here are the different volumes for the manufacturing scale horizontal bead mill, volumes in liters per hour, so we can really produce some massive amounts of product. And we have actually gone larger for some custom applications. So if you're really looking to produce massive volumes, we can definitely help you there with a customized solution. Again, ceramic option, all zirconium lined, as well as zirconium rotors. Then we have the manufacturing scale. We can go up to about 2,000 liters of product volume, roughly about a little bit like 600 gallons. Output 55 kilowatts. We have different control capabilities. So we have the standard SPS or SC, and then we have a Siemens control panel. If you want to integrate a scale, we have that ability to also offer this package as well. We have a vacuum capability with the SC. We offer a wall scraping system for really thick materials. If you want the entire slurry to be processed with the wall scraper, that's an add-on. That's also helpful for slurries that are very thixotropic. And then we also offer explosion-proof designs. And the quick change system, again, I talked about it earlier, is available that allows you to seamlessly move from a dissolver over to a basket mill. So they're very, very quick change systems. I can move from a disperser to a basket mill in about 3 minutes. I can move from one to the other. So I only need one piece of machinery for my entire dispersion and milling process instead of buying multiple pieces of equipment. So that's a big advantage. Here you can see how the quick change system works. So I start out with a dissolver, and then I'm ready to do milling, and I just swap out the dispersing blade for a basket mill. And again, we have full ceramic option, zirconium lined milling chamber, as well as zirconium milling disc with our basket mill systems. This is the stand that will come with the machine that basically allows you then to move seamlessly between a dissolver and a basket mill, all on the same machine. Then we have the Dispermat SC with the vacuum system. Allows us basically to better wet and disperse our materials. It allows us to remove any type of foam from a homogeneous type of dispersing action. Cost savings and small. I don't have to use really defoamers. There's variable vacuum pumps depending on the product volume. Again, we can offer that nitrogen purging valve, and it's really designed for large scale manufacturing, all again up to 2,000 liters of product. We have also, this is a really interesting concept. This is the 2-in-1 system, where before I showed you where you're moving between a disperser and a basket mill on one machine. Here I have both systems integrated in one machine at all times. So I pre-disperse first, and then when I'm ready to do milling, I don't have to make any changes. I just push a button on my control panel, and then I can lower a basket mill, and now I have a fully functioning basket mill system. Also on one machine. Here the product volume is somewhat less. We can go up to 1,600 liters with that type of design. It's called the Dispermat TM. Again, here you can see another slide of the TM. Once we're completed with the pre-dispersing, we push a button, the basket comes down, and now we have the basket mill. Of course, huge advantage, space savings, time savings. I don't have to move containers around from one machine to another. I can do everything on one machine. Simple cleaning. I don't have to move baskets. I can literally do the entire dispersing and milling process on one machine pretty much at the same time without having to make any changes. We get really good milling results with our basket mill design. I showed you that earlier. So these are awesome machines. The threshold there is about 500 nanometers. If we want to go lower, we really need to move over to a horizontal bead mill. Here is two systems, TM1000s, installed at a customer. Same machines. The cowls blade is not installed yet. It's behind the gentleman on the left. And you can see the basket mill right on top, below the cover. And then over here on the right side, it's the same machine, except it's collapsed, it's lowered. That's what it would look like when you are basically running the machine when you're pre-dispersing. And then the basket comes down when you're milling. Also, may I mention, very quiet, that stepless, that brushless step motor design allows for really quiet operation and headset worn to communicate with Germany, but not running the machine yet. So, but very, very quiet. Here is an up-close view of the basket mill. So double-walled, excellent cooling capability. So we have these bars right here. On the right side is coolant or water in, and then on the left, water or coolant out. We have a third bar in the background that is actually used to measure the temperature inside of our basket mill. And that screw right here basically it gets removed to add the beads to our basket mill. We have a very efficient basket mill design. Our screen is on the bottom. We don't have screens on the side like some of our competitors. The huge advantage is that there is much less wear on the equipment because of the way that the beads get thrown around inside of the milling chamber. If you have screens on the side, this is where you will experience most of the wear. So That's one reason. The second reason is most of your energy gets created right in that area. So we want to be really, um, have a very good cooling in that particular zone. So we removed the screen and basically made that whole thing double walled for excellent cooling capability. To draw the slurry out of the container, we use the cow's blade on the bottom, and we can then effectively draw basically our slurry out of the basket and then push it back to the top. So huge advantage there. Again, we don't have any seals or washers like what you would have in a horizontal bead mill. Excellent temperature control. We also offer a vacuum system, and basically we have an integrated pumping and steering wheel to draw the slurry into our basket, and then here is your milling disc with the screen right below. A very, very nice design. Here you can see that on the left side where basically the slurry gets drawn out of the basket through the screen. So the beads are kept in there, and then basically they get pumped to the top with the cow's blade, pushes it up, and then that pumping and steering system will create a vortex and then suck it back in. So we have very efficient motion in and out of our basket. Really good design. Then we also offer what I talked about earlier, the vertical bead mill APS system. This is more for a lab space, not really for large scale manufacturing. We can go up to about 35 liters of slurry with this system. So we basically have two containers, on the top container and the bottom container. On the top container, we have our slurry. If we want to mill, we just add beads, replace the cow's blade with the milling disc, and then we are milling. You can see on the bottom of that container, there is a screen in here and a drain plug. When we are ready to purge our slurry, we plug an air hose into our cover and then basically pressurize our chamber and force the slurry out of the container into the catch pan or another container below. So that will be our milled material. Once that is fully milled, I can put the drain plug back in place and then add cleaning fluid or any type of solution with the right polarity, run it for a few minutes, purge it out the same way, and that's how I'm cleaning my APS system. Very efficient, but again, small scale, perfect for lab space to do a lot of samples very quickly, all the way to small scale pilot. Not really suitable for large scale manufacturing, just because if I have 2,000 liters, I would need a lot of beads to really mill the material. It becomes very inefficient at that scale. Because we can add 100% of our slurry, we can add in beads. So if I have 500 milliliters of slurry, I can add 500 milliliters of beads. So we have a lot of milling action going on in our small containers. Just different control panels here. So you can see that C technology with the new renewable energy package. We have the speed display top left. We have the energy input in watts. We have a torque value displayed. The tip speed on top right. We have a temperature readout as well as our timer function. The device also comes with that those safety features, a container clamping system. You can see we have two buttons right here. They allow you to set a threshold for the lower limit as well as the upper limit inside of your container. So you would preset that before you start dispersing or milling to ensure that basically you can operate within those two set points. If somebody were to inadvertently push the up button and it would pass the threshold that you set, the machine would automatically power down or stop at that reference point so that there would be no way somebody gets injured with this spinning disc outside of the container. also for the bottom threshold that would ensure that you wouldn't be hitting the container bottom with the disc or the milling system. You can also add a light feature to see what's going on inside of the container. You can add an oscillation feature that basically allows for the shaft to move up and down at different rates, depending on what materials you're trying to process. On the right side here, you see the simple version of the control panel, more for manufacturing, very easy. Sometimes in these manufacturing environments, it gets very dirty or dusty. So this is a more sturdy approach to the control of the machines. Then we have lab space available in Germany, where we actually build all of our machines. We can have you there to do some trials on the equipment, proof of concept testing. We also have a large upscale and small manufacturing facility. If you wanted to see how the larger basket mills or horizontal bead mills functions or the solver with your slurries, we can set that up. And then here in North America, we have a smaller lab. This is some of the new equipment we added for doing small lab trials in our Wallingford facility. The advantage there is we work in conjunction with our sister company, the Big Additives team, and they have some really good innovative solutions for electrolyte as well as separator development and processing. So we offer different types of surface additives, defoamers, as well as dispersing additives that go into your electrolytes, cathode or anodes, or the separator material. So if you come and visit, we can then tie in one of the chemists to give us support on the development side to ensure that you get optimum performance, not only from the equipment side, but also with the additive packages. So the Wallingford site in Connecticut is located at our sister company, Big USA. It's a first-class laboratory facility. We have the Battery Additive Development Center, all for energy storage solution processing. So we can really show you the type of equipment for your application, run different trials on the different milling systems. We can also scale up as well. We don't unfortunately have really large scale. We're in the process of adding that capability, but we do have that in Germany. And then again, we can really leverage those synergies we have with the additive business and our instruments business really nicely. The lab is great. We can use it also as a showroom if you want to come in and look at the equipment without actually running material. We can set that up, and then it also functions as a training location or a seminar location for our customers. And that's it for today. Thank you very much for joining me today.
Great information, Andy. As always, we appreciate the time and expertise. Like I said, you'll be getting a marketing email, automated email immediately following this, where you'll have a link to this recording. Feel free to share it with colleagues. If you have any questions at all, just hit reply. It'll come back to our marketing team, and we'll route it to the right technical expert. Also, Andy and I are working on a pretty extensive white paper around dispersion and milling for energy storage. So stay on the lookout for that. As soon as we get that done, we'll definitely get it on our website and promote that out to you. So with that, have a great rest of your day, and we look forward to seeing you on future Big Instruments webinars. So thank you, and thanks again, Andy.
Thank you.